Hi there grade 12s and welcome to this lesson for Life Science grade 12. Today we're going to be having a look at the structure and function of the eye, how it ties in with the nervous system, and we're going to be having a look at how the eye works and at some different defects that can affect our vision. So let's start off by having a look at the structure of the eye and some of the functions of the various parts of the eye. We'll start off by having a look at this diagram beside me. The first thing we should notice, or the first structure of the eye we should take note of, is the lens. The lens is a structure that changes its shape to support accommodation, which we're going to learn about later. And accommodation is basically just the process that allows us to focus on distant objects and closer objects. We then have the iris. The iris is the colored part of your eye, and it's essentially a muscle. The hole in the iris, known as the pupil, gets bigger or smaller to allow more or less light into the eye, depending on the conditions, whether it's bright or darker. Then we have the pupil, which is the circular hole, which is surrounded by the iris, as I've already explained. The iris is held in place by what we call suspensory ligaments, or rather the lens is held in place by the suspensory ligaments. We also have a liquid and substance called the aqueous humor between the cornea and the lens. This helps to support all of these structures. The cornea of the eye is also responsible for refracting light and helping you to focus on objects. The retina then surrounds the back of the eye. This is made up of light-sensitive receptor cells known as rods and cones. The sclera is the white part of the eye. It is a fibrous, tough material that helps to keep the eye, give the eye structure and protect it. We then have the choroid. The choroid is a dark-colored layer, and what this does is it reduces reflection of light inside the eyes, and it's rich in blood vessels to supply the eye with the blood supply it needs. We then have the optic nerve. The optic nerve is a nerve which carries impulses from the eye to the brain. Where the optic nerve meets the back of the eye, we have the blind spot. At this spot, we don't have any rods and cones, so light that falls onto the blind spot is not interpreted as an image by our brains. We also have the yellow spot at the back of the eye, and this is where we have the highest concentration of these photoreceptor cells. Finally, the larger part of the eyeball is filled up with a fluid known as the vitreous humor. Now, don't get confused between the vitreous humor and the aqueous humor. They are on different parts of the eye. Now that we've looked at the structure of the eye, let's go on and have a look at how these parts come together and function to allow us to see images. Okay, so what happens is that light passes through the cornea of the eye. It then passes through the aqueous humor into the pupil. The lens helps to refract the light so that a clear image will form on the retina. So after passing through the lens, the light then travels through the vitreous humor and eventually forms a clear image on the back of the eye where the retina is. Now, most of the refraction that occurs, because remember we are picking up light from a big area and this needs to be focused to form a sharp image on a much smaller area on the back of your eye. So most of the refraction of light that occurs happens when light enters the cornea and when it exits the lens. The cornea is where most refraction takes place, and the amount of refraction in the cornea remains relatively constant. It doesn't change depending on whether we're looking at something close or far away. However, the lens is elastic and the curvature of the lens can change. In other words, it can be more curved or less curved, depending on how far away the thing we're looking at is. This process is known as accommodation, and we're going to have a closer look at it in a few minutes. Now, once the light reaches the retina, we have specialized photoreceptor cells called rods and cones. These are stimulated by the light. The photopigments in these cells are broken down by light, and they generate an electrical impulse, which is then carried by the optic nerve from the eyes to the brain, where these impulses are interpreted. Okay, now I've already mentioned the term accommodation a few times. Accommodation is the change in the shape of the lens of the eye that allows a clear image to form on the retina, whether an object is far or near to us. So when we look at a distant object, first of all, the ciliary muscles in the eye relax. The suspensory ligaments then tighten or become taut. This puts tension on the lens and pulls the lens, causing it to become more flat, or in other words, it's becoming less convex. The light rays are then entering the eye are then bent less, and the light rays are focused onto the retina. That's what happens when we're looking at something far away. When we are looking at something closer, the exact opposite happens. The ciliary muscles contract. The suspensory ligaments are then slackened. They're putting less, they're pulling less on the lens, so the tension in the lens decreases. This allows the lens to become rounder, to become more convex. This means that the light rays are more refracted, or are refracted more, and this focuses the light then to form a clear image on the retina. Another process we need to know about that occurs in the eye is our pupillary reflex, or pupillary mechanism. This you might know, or at least you have seen. It is when we go, for example, from a dark room into one that is brightly lit. I'm sure you've noticed when people do this that their pupils, as they walk into the brighter area, suddenly get smaller because the eyes need to let less light in. This is the pupillary reflex or mechanism. Its function is to regulate the amount of light that enters the eye by controlling the size of the pupil. So, how this works is that when light is bright, the radial muscles of the iris relax. The radial muscles are the muscles in the iris that go lengthwise. The circular muscles of the iris then contract. The circular muscles are the muscles that go in a circle around the iris. Because the radial muscles are relaxing, they lengthen. The circular muscles are contracting, so they're getting smaller. This means that the iris, or the size of the pupil, gets smaller. Because the pupil is smaller, that means less light is able to enter the eye. This will happen, for example, when we stand in bright sunlight. But let's say it's dark, load shedding has happened, and you don't have any candles at home. What happens to your eyes now? Well, the exact opposite will happen. First of all, the radial muscles of the iris will contract. They'll get shorter. The circular muscles will relax, so they will become larger. This causes the iris to get smaller, and therefore causes the pupil to get larger. This means that more light can now enter the eye. The first thing we're going to look at is a very common eye defect. We all call it short-sightedness. In other words, you're only able to see things that are close to you and battle to see things that are far away, or the things that are far away look blurry. This, like I said, is called short-sightedness, or lots of times people will call it myopia. Now, it's usually because the shape of the cornea is wrong, or because the actual shape of the eye has become deformed. Luckily, it's an easy condition to treat. We just need glasses. In the case of myopia, we need to use concave lenses to sort this out. The lenses, the concave lenses, help bend the light a bit before it enters the eye and allows us to then make a clear image on our retina. We then have long-sightedness. Long-sightedness is the opposite of short-sightedness. This is when we can see things far away well, but we battle to see things that are closer. Many of you may have parents or grandparents who use reading glasses, and this is because they suffer from long-sightedness. Long-sightedness, the proper word we can use for this, is hyperopia. Now, just like myopia, hyperopia is caused by the cornea being the wrong shape or by the eye itself being the wrong shape. And just like myopia, it can be treated using spectacles or glasses. In this case, however, it is treated not using concave lenses, but using convex lenses. Okay, so another condition we can talk about is astigmatism. Astigmatism is when we have an incorrect shaped cornea, which causes multiple images to be formed on the back of the eye. This can be treated by using hard contact lenses or laser surgery. And finally, we have a condition that many older people get known as cataracts. This is when the lens is affected and starts becoming cloudy because the proteins start hardening. This can be treated using laser surgery. Guys, so that's it for all the information on the eye. Join me for the next part of this lesson when we'll be looking at different questions and answers that you can expect to see in the exams. I'll see you guys in a few minutes.